Hey guys, this is Craig Migliaccio with acservicetech, and today what we're going over is pulling a vacuum on a heat pump. So this is a residential system, it's a 4-ton unit, and we're going to be pulling the vacuum and breaking the vacuum with refrigerant from the bottle. Now we're going to know how much refrigerant to add into the system because there was a 50-foot line set, and this is the cutoff piece. So we're just going to subtract this from the 50-foot, and we're going to use our refrigerant weight calculator on our website in order to determine how much refrigerant we need to break the vacuum with into the system. After we do this, we're going to go ahead and check the refrigerant charge while the system is running, and we're going to do that with the subcooling charging method because this system has a thermostatic expansion valve. So we're going to go ahead and get started now. We just brazed the line set in, and we also pressure tested the tubing, and we pressure tested it to 320 psi. There's no leaks, and just so you know, we had removed the valve cores here before we even brazed the tubing in. So we had these set off to the side. Now when we're getting ready for a vacuum, we always use 2 valve core removal tools, so 1 on each port, and that's so that after we have positive pressure in the lines, we can go ahead and put the valve cores back in again. So I have this 3rd valve core removal tool here just to be able to valve off my vacuum gauge to make sure that I don't get any oil inside the vacuum sensor, but a lot of people just use 2 valve core removal tools. I like to use 3 just to protect that sensor. So we're going to go ahead and turn the vacuum on in a second. Also, just so you know, we have these service valves are front seated all the way. So this unit has refrigerant in the outdoor unit. So what we're going to do is once we get down to the proper vacuum level, which is below 500 microns, we're going to add refrigerant into the liquid line. And after we do that, that's when we're going to open these valves up. So here we go. We're going to turn the vacuum on. So it's going to take a little bit just to start getting a reading back here. I know you can't read it very well, and we don't have a reading quite yet. It takes maybe about 30 seconds or so before we actually are going to see something. So there you go there. And what we're doing is we are vacuuming out any moisture out of the lines, any air, any nitrogen. And we already did our pressure test, so we know that there's no leaks. You want to make sure to do a pressure test before vacuuming, otherwise you're going to be pulling air through the leak and into the tubing, so you want to avoid that. So what I'm going to do first is I'm just going to close and open each one of these valves just to get any air that's around the little ball of the valve. We want to get that out of there. And right now you see we're around 1,000 microns right there, but we should start pulling down again here soon. So we're at 970 microns. We're probably going to target right around 200 to 300 microns. I know you can't see it very well. 820 microns. Once we get down, I'm going to turn these valves again. It just happens to be like a little bit of air that gets around these valves, and so that's really the only reason why I'm shutting them off and opening them back up again. After we pull down to right around 200 or 300 microns, what I'm going to do is we're going to do a standing vacuum test, which means that we're going to close this valve and close this valve, and we're going to turn the vacuum pump off. And then we're going to time it for 10 minutes. And just to see if the vacuum level rises over here. And if it continually just steadily rises, then you know that you have a possible leak, in the system, especially when it just keeps rising and rising and rising. If it rises a little bit and then stops, and then it rises again and stops, there might be a little bit of water in the tubing still. This was brand new line set tubing, so I don't believe it's going to rise much. Right there you see about 370 microns. So it really shouldn't take very long for a vacuum. There's no point in pulling a very long vacuum because all you're doing is just wear and tear on your vacuum pump. As long as you remove the valve cores, a vacuum won't take very long at all. And you are doing the right thing. You're not freezing any water in the system. If you're trying to pull a quick vacuum, at least on these, a residential split system, all this tubing is exposed to the air. I mean, all the tubing in this particular unit, this tubing is going up into the attic. So it's a very low likelihood of any water freezing in here. The only way water would freeze is just that you're pulling the heat out of the tubing, but the tubing is absorbing the heat around it, and so it should be fine. So we're boiling any water that would be in the tubing. We're boiling it and pulling it out. I'm going to go ahead and shut each one of these valves. So 240 microns right now. We'll pull down right about to, well, maybe right around 200, and then we'll do our standing vacuum test. Now when we break the vacuum with refrigerant from the bottle, we're going to weigh the refrigerant into the liquid line. And the reason for that is we're just going to have a very short hose attached to this valve core removal tool. We're going to purge the air out of the hose, and we're going to have it connected right here. And we're just gonna add it in with this valve. The reason that we're doing that and not going through a manifold is because we don't want the refrigerant to expand. So you can weigh in a decent amount of refrigerant into a system if you keep it in the liquid line. If you try to put it into the large vapor line, it has room to expand, and then once it expands, it applies pressure against the bottle pressure. You're just not going to get much into the system. All right, we're at about 210 microns right now. Once we pull down to about 200, I'm going to go ahead and shut these valves. So there we go. We're at 200. So now our vacuum pump's shut off, and our 10-minute standing vacuum test is going to start. Our vacuum gauge just shut off. Let's go ahead and turn it back on. A lot of times when the vacuum gauge shuts off and turns back on, it reads maybe 10, 20 microns higher than what it was. And it was at 230 microns, and that was after right about 10 minutes. But we'll see what it reads now. But we're gonna go ahead and break the vacuum with refrigerant from the bottle into this line. So you see we're reading 250 microns right now, that's fine. We're gonna go ahead and switch the camera views, and we're gonna come over to this side. So what I have is a service hose without a valve core. So I'm gonna attach it right onto my R410A bottle. I'm gonna close this handle. We're gonna turn this upside down. This is a brand new bottle. So my handle is shut. What I like to do is to isolate the hose. So I just put it right under there. And what we'll do now is we'll take this off. We're still reading 250 back there, so we're good there. Turn our scale on. So what I'm going to do is I'm just going to purge the air out of this hose right now. Okay, so that's it. So we have a good connection from here to here, and you can just, when the air is purged, the noise change, and if a little visual change, you want to make sure to not just continue to allow refrigerant out, but you do want to make sure that you get the air out of the hose, because you don't want to put air into a brand new system, so that would be terrible. So now I'm going to go ahead and zero this out first. Make sure that I don't touch this refrigerant bottle. I'm going to shut my vacuum gauge, and hopefully you can see this. I'm just going to go ahead and weigh in 9 ounces. So we weighed in a little bit more than 9 ounces. We weighed 10.6. Now this unit comes with enough refrigerant for 15 feet with a line set and an evaporator coil. So we know that we needed to add an additional 9 ounces to the refrigerant charge that's in this outdoor unit, because we started off with a 50-foot roll of line set. We cut off a section outside, we cut off a section inside, so we know that we have 28 feet worth of line set length. So that's why we had to add enough refrigerant for the additional 13 feet worth of line set. So that's where we came up with 9 ounces. So if you go to our website, go to the refrigerant weight calculator, and you select R410A, you select 3/8 for the liquid line, and select 7/8 for the vapor line, and you have 13 feet, you'll see that we have to add 9 ounces of refrigerant. So we accidentally added just a hair more, and that's okay. We'll just go ahead and shut this off here. And now that we have positive pressure on both sides, we're gonna put the valve cores back in, and then we can go ahead and turn the system on and check the charge. So now I'll put the valve cores back in. And I'm gonna purge any air right here, just a little bit. The other thing is I'm going to back this up just a little bit because the rubber insert that's in here is really squished because I wanted to make sure it was tight. You don't want to unscrew it off or else it'll blow right off. So you got to be very careful with that. But you want to make sure that the valve core doesn't get hung up on the rubber that's right in here. Pressing in and turning. And now I'll just take that off. And just make sure it's not continuing to leak. We'll do a final leak check of the valve cores after I check the charge, but for now, we'll just take these off and we'll attach our manifold gauge set in order to turn the system on and check the charge. So I'm gonna do the same thing for the back. So once again, we'll do a final leak test after we check the refrigerant charge. But first I wanna go ahead and open up these service valves. Do the liquid line first. There's no need to backseat these. These are not backseating valves. They have an O-ring in order to seal it, so you don't have to like crank up on it. Now open up the suction valve. And now we'll connect our digital manifold gauge set. Now we have our digital manifold gauge set. We want to go ahead and turn that on. And so we see 410A. So, and then you also want to make sure that it has 0 psig and the liquid line temp and suction line temp are the same. You know, they're not connected to the lines yet. And then we're going to go ahead and hook our hoses on, and then we're going to go ahead and turn the system on and check the charge. Our blue hose goes onto our suction line, which is our vapor line. And now we're going to get the inside unit running, and then we're going to hit the disconnect up here because I want to make sure that I'm out here when the unit turns on. I just want to listen to everything. So then we'll go ahead and check it. Now I'm going to purge the air out of the lines right here. With this valve shut, I'm going to go ahead and open this up, and I'm just going to just gently, okay, so you can hear the noise difference right there. And then we'll go ahead and close that back down again, and we'll do the same thing for the vapor line. You're not going to hear much of a difference with the vapor line because it's only gas. Whereas the liquid, we did hear a little bit of a difference right there. So now we purged the air out of these two hoses. I'm also going to attach my yellow service hose right in here. Actually, we'll purge the air out right here too. So we're going to make sure all these are shut. We're going to take our liquid line clamp. We'll clamp it right here. Take our vapor line clamp. Clamp it right there. And we'll go ahead and push the disconnect in. Our indoor fan is running and we do have the correct amount of airflow. We should have 1600 CFMs of airflow and we're at about 1630. So we are good, and I'm going to go ahead and push the disconnect in. So this system's been running for about 10 minutes or so, and you can see our vapor saturated temperature at the evaporator coil is 52.4 degrees. Our superheat is 8 degrees, so our TXV is doing its job, trying to keep the superheat around, say, 8 to 16 degrees. So you want it somewhere around there. But yeah, it's very efficient at 8.6, and we do have a good superheat there. Our subcooling is at 10.8, so we're very close to what's up on the rating plate. It says 12 degrees of subcooling. Our liquid saturated temperature is 85.7 degrees. So remember that our pressure right here, the only reason we even check pressure is to convert them to saturated temperature. And so we were very close to our target subcooling up on the rating plate of 12 degrees. What I'm going to do is I'm going to add just a little bit more refrigerant into this system. And I'm just going to add just a hair more here. And also this unit has a heat pump. So as long as we're adding refrigerant into that vapor line, everything is fine because it still goes into the accumulator tank. That protects the compressor, so that's nice. What I'm going to do is I'm just going to go ahead and shut my bottle right here, and I'm going to weigh the rest of the liquid refrigerant that was in this bottle into the system. So we're not going to worry about what the scale says right now because I just moved it all around. Depending on where this hose is at, it would change the reading, but we're going to weigh the rest of the liquid that was in this line right here into the vapor line. You got to be real careful when charging systems that don't have an accumulator on the suction line protecting the compressor. Alright, so that's that. You see our subcooling is approaching 12 degrees, but what we're going to be doing here is we're going to be charging the refrigerant that was in this hose. We're going to be charging that into the vapor line as well. It's called the disconnect procedure. So I'm just going to go ahead and shut this valve, and then we're going to unscrew that, and this way we get a lot of the liquid refrigerant that was in this hose back into the system again. So we are looking at 11.3 degrees. And maybe I'll give it one more shot down here. I'm going to give it a little bit more. I'll just fill my yellow hose up. I just shut the tank back off again. I'm just going to charge that amount in. I'd prefer to be right around 12-13 degrees. Okay, so that's it. Now I'm going to go ahead and shut this off. We don't need our clamp on this liquid line anymore, so I'm just going to go ahead and put it back. And we'll still monitor our superheat. What I'm going to do now is I'm going to shut the valve on this liquid line, and I'm going to unscrew this quickly. But anyway, we unscrewed that, so this is still full of liquid refrigerant. And what I'm going to do with that is I'm going to just open this line. So we're going to have refrigerant from here go into here, and then it's going to go into the vapor line. I just want you to note that we have this is basically empty and this is shut off. It just has vapor in it, but just for your sake, just so you can see it, I'm going to turn this valve there. I'm going to go ahead and open up this, and I'm going to go ahead and open up this line right here. This is the high side. So you see that the high side and this service hose are connected right now. We're going to leave this shut, and we're going to charge this refrigerant into the vapor line. You want to do that until the pressures on both the high side and the low side match. And that means you have all of the liquid out of the hoses and you just have vapor left. So that's it. So I'm just going to go ahead and shut these. So we have vapor in all three hoses because we charge the liquid out of here, so there's only vapor left. and that's that. Now we can go ahead and disconnect the vapor line. So I'm just going to check the Schrader valves back there on the ports, and just to make sure that they're not leaking. Then I'm going to go ahead and put my locking caps on. But that's how you do it. So if you want to learn more about the HVACR field, check out our website at acservicetech.com. We have a lot of different resources there, such as HVAC calculators, articles, almost 400 videos, a bunch of Q&A. Also check out our refrigerant charging and service procedures for air conditioning paperback and ebook. We also have a 1,000-question workbook that goes along with that, and the full outline and sample pages can be found on our website. We also have our physical products for sale over at amazon.com/shop/acservicetech. So we have our ebook for sale at our website, and we also have our ebook for sale over at Google Play. So I hope this helped. Hope you enjoyed yourself, and we'll see you next time at AC Service Tech channel.